Today I'm going to solve a comprehensive question that illustrates how to calculate forces on a vertical face over here and a horizontal face over here. And it's a depth into the screen is 1 meter, okay? And I gave you the specific weight of the liquid that I have here, and this is seawater, okay? And I said that the P gauge right over is 0 because it's a free surface over here. In the next segment, actually, I will focus on this as well. So you will have different solutions to different kind of questions, okay? And what I'm asking is, what is FP1, what is FP2, what is center of pressure for the first one, and center of pressure for the second one, okay? And I define my Y this way, and Z is pointing up, surface number 1. So what will happen is, you can imagine that there will be an Fy over here for surface number 1. I'm going to assume that the thickness over here is negligible, so there will be no force or no weight above the surface all the way to the free surface, okay? Alright then, so let's just write it down. So if we write it down, what will happen is my FP1 will be Fy1 in the J direction. So let's take a look at it. Yep, right? So Fy is pointing this way, Y is pointing that way. That's why I put a J over here. So now the only question that I have here is, what is the Fy value? Okay, so let's go ahead and calculate that. And I will show you today 3 different approaches. Each approach has advantages and disadvantages. I will discuss this along the way. The first one I want to do now is called the integration method. So let's take a look here. So what I'm going to do is I will actually draw this in 3D, this surface number 1. So it looks the surface number 1, 2 is the height, and 1 is going into the page. So something like this. Okay. So what I'm going to do over here, I will pick a small slit like this. Okay, a tiny little bit off, and I'm going to say the height of this is dz. The reason is that z is pointing in this direction. Will you agree with me if I say that the pressure over here is constant, because dz is such a small height that the pressure simply can be assumed to be the same over here, and it's a fairly reasonable assumption. But please note that I'm not assuming pressure here is equal to pressure here is equal to pressure here, something like that. That's really not the case. The pressure is increasing linearly as I go down, right? Okay, so, and into the page is 1 meter, so let's write that as well. And then, well, let's go ahead and calculate what I need. I said that, hey, I'm going to calculate my dFy will be equal to, I said it's a constant pressure, and I'm going to use gauge because it's easier, times the dA. I mean, you knew this formula for, since high school, right? This is the pressure times area is equal to force. It's a little bit more fancier. I'm taking a differential analysis over here, okay? Then what I'm going to do is I'm going to look at what is dA in this particular case. You can see it. It's dz is the height of it, right? And 1 is into the page. Okay, let's plug it in. So then I will get myself pgz times dz. I'm going to draw 1 over here because multiplication 1 doesn't matter. One thing that I want to highlight here is you need to be careful. Everywhere that I have in this particular question is open, and everywhere is atmospheric pressure in here. So even if you use the absolute pressure over here, what you will do is there will be P ATM times this area over here, but on the other side of the surface it is also pushing it, so they will cancel each other at the end of the day. Okay, so gauge is the strategic move over here. Okay, so let's continue. So then what I'm going to do is, one of the classics is you take the integral of both sides of these equations. So you take this integral, and see what happens. The integral on the left hand side becomes Fy, and the right hand side becomes, over that area that I have, it's going to be Pgz dz. Okay, so now the next step is to insert what Pg is, and this is coming from module number 2. We discussed that, so I'm going to plug it in. It's minus specific weight times z. I'm assuming this is incompressible, and I gave you seawater, so then it's a fairly reasonable assumption. So if I do that, what I'm going to get is minus specific weight times z dz. So let's be careful about the limits of the integration. Okay, so just want to highlight, I'm sure you know, but I'm just repeating myself. So the smaller number, mathematics speaking, will be here, larger number over here, okay, from mathematics. So now, if I look at the boundaries of my surface, the lowest number will be -5 because z is pointing up, and it will then end at -3, right? So let's write it. So then it's going to go from -5 to -3. Let's go ahead and evaluate this integral. It's going to be minus specific weight times, what is the integral of z dz? That's going to be z squared over 2. And I need to insert -3 up there, -5 down here. And then the next step is to insert just the numbers. So it's going to be minus, I said this, 10,000. Please remember to convert to newtons. Kilonewton is not the unit of SI, right? Z squared, so let's just write it, -3 squared divided by 2 minus -5 divided by 2. Let's take a look. So this becomes what? Plus 4.5, right? Because -3 squared is plus value. And this becomes what? 12.5. And then so I have a negative sign here. So this becomes -8. -8. So at the end, I'm going to get a plus 80,000. What's the unit? Newton. Or I can say 80 kilonewton is my final answer for this particular force amount. Okay, 80. So this was the approach number 1. I said integration. Some students like this because they want to stick to mathematics. They feel much more comfortable with the mathematics as opposed to physics-based approaches. So that's perfectly fine. Then let's go ahead to the second method. Let's call this alternative method 1. I'm going to call this equation. Okay, there will be an equation and I'm going to write it for you. Fy will be specific weight times hc, which is the geometric center of the plate, I'll write it down, times dA. Okay, and if you are looking at the Manson-Young-Kokishi 8th edition, this is 2.18. Okay, and then I'm going to define what h is. As I mentioned, it's the geometric center of the surface. Geometric center, fairly easy to find. Okay, let's go ahead and find my Fy using this methodology. So this is going to be 10,000, very similar to the first approach. And in the second approach, I will have an HC. So let's take a look at it. Where will be the geometric center? Please note that I will talk about something called center of pressure. Those are not the same, okay? Geometric center is simply, if this is like 2 meters, the geometric center will be right in the middle of it. So it will be 1 meter over here. So let's write that. The geometric center will be here. So this height will be 1 meter. So you can see 1 meter and there's a 3 meter over here. That becomes 4 meters. Okay? So that will be 4 meters. And area is, height is 2. Going into the page is 1. You write here over C that you're going to get 80,000 newtons, right? So this is the approach number 2. So you need to be careful about this approach though. When the books discuss these, they don't really mention about the limitations of it. Okay, so for instance, you have if you have 2 fluids in your system, yeah, I understand this can be manipulated, but students don't typically see that. So careful about this equation. If this is a simple case, such as you have an incompressible, a single liquid with a constant density, etc., you should be able to use this fairly easily. Okay. Then let me go ahead and introduce you to alternative method 2. And the alternative method 2 will be this. It's called geometrical method. Some people call this geometrical method. I like to call this pressure prism because you always get a prism method. Okay, let me go back and explain what's going on over here. All right, now, so we do know that the pressure here, as I'm using gauge terminology, is 0. Okay, and if you look at how the pressure changes, that will be right over here. The pressure is going to increase. Remember, Z is pointing up, that's why I have a negative. So when I'm going down, the pressure is going to increase linearly as a function of Z. And the linearity constant is this specific weight. If I show you over here, what will happen is the pressure is going to increase linearly all the way till it reaches the bottom. Okay? So for instance, it's not a function of whether I have an angle over it. It just simply goes as a function of Z. Right? So then if I look at this section where it is related to this area, I should be able to get something, and I'll show you how to do it. Okay, let's do the geometrical method, or pressure prism method. This is the surface, it's free surface. I will go down 3 meters to start my surface, and then it will be over here for 2, right? That's what it is, and I have end over here. Okay, so if I look at the pressure distribution over here, it's going to be specific weight times z, so that means it's going to be changing linearly. If I look at the pressure distribution on my surface, and you will see I'm going to get something like this. Okay, and the slope of this line will be the specific weight. Okay, so this is 3 meters, this is 2 meters, let's write those. And let's just calculate it. F will be P average times the area. How am I going to calculate P average? That is the question. Well, if there's only one fluid in my case, you can see that this is linearly. If I have a linear, then I can simply go ahead and calculate PA over here, then PB over here, sum them up and divide by 2, as this is a linear change. So let's say that I have 2 separate fluids, and the fluid one is down all the way to here, and the second one is over here. Well, I'm going to then treat them separately. I will do F1 from here to here, F2 from here to here, and then it will still be linear within each fluid. Okay? It's going to be point A, this is going to be point B. So now I'm going to get PA will be equal to specific weight times the distance that I travel down, which is 3. How about PB? That will be the specific weight times the distance that I travel down, which is 5. So now my P average will be PA plus PB divided by 2. And so if I plug numbers in, this is the specific weight times 3 plus specific weight times 5 divided by 2. So then I get myself 4 times specific weight. So now I want to actually go back and relate this to the second method, or alternative method 1. Take a look at it. Okay, I didn't drive it for you to save some time, but this is this, right? HC. HC, geometric center of the plate. Did you see something over here? When I average PA to PB, then I pretty much get the pressure at this geometric center of the plate, right? So you can actually, I can even draw this like that, as this is symmetric. So I can something like this. You can see this area will be this area. So basically it's over here, and that is right at the geometric center. So you can see there's nothing fancy going on in this equation. It all makes sense. It's the same thing that I'm talking about. Okay. However, this is not visually, if you are making a mistake, you can catch it by alternative method 2. In the alternative method 1, what you do is you plug numbers in and hope for the best. Okay. So you get yourself P average over here. Then F will be P average, which is 4 times specific weight times area is 2, height 1 into the page. Now, obviously this is 10,000. So I get myself 80,000 for my Fy value this time around as well, which makes sense. It's the same thing that I'm doing here, right? So when it's all said and done, you can see that my Fp will be equal to, Fp will be 80,000 in the positive J direction. Okay, so now we find this force. Now the question is, where is this force acting? This is quite related if I have, there's typical questions. It's very similar to your statics courses. So this can be hinged over there, for instance. It's important that I know where the pressure is acting, whether this gate is going to be open or not, right? So there's a bunch of different questions like that. But the fundamentals is coming from your statics courses. There's nothing new in here from that angle, okay? You just calculate the moment with respect to this particular point. You call it O. Let's say that the pressure force is acting here. It will be a little bit below the center. This is the center. So let's say it's acting in here. Then this distance times that O will be the moment. And the rest is exactly the same what you've been used to. So there's nothing new in here in a good way. Okay. So actually, I will go to the previous segment. And I have the notes up here. You can see my geometry is this now. Okay, and my B, look, X is into the page. So my B in this particular case is 1, A is 2. Okay, so area is B times A, so we know that. And this is what I'm interested in, IXC. Okay, so that's what I need. So this is a formula-based approach, and you can see XR is equal to XC. This is given as well. So if I'm interested in what is the center of pressure going into the screen, well, it's going to be right at the middle. It's going to be 0.5, right? So okay, let's just do what I just said. So my yp will be equal to yc plus ixxc divided by yc times a. What is yc? Geometric center. We looked at an alternative method 1, right? This is 4, if you remember, right? Area is 2, yc is 4. Let's look at ixc. That's going to be 1/12. So a is 1 into the page, and the b is 2, right? The height to the power of 3. Okay, let's see what's going on in here. So okay, this is going to be 8. You can see 4 times 8, so these cancel out. Okay, so from here I get my yp is equal to 4 times. So always there's a little bit addition to the geometric center distance. It's going to be, you see, 1/12. So now what is this? 49/12 or 4/1. So it becomes 4.08 times, yep, 333. This is what it is. So this will be the distance that I obtained from the surface, 4.08. So as you see here, we discussed that when I was talking about the pressure of center, center of pressure rather. You can see that it is not here, and this distance that I obtained from to here is fairly small, right? So this distance is 0.083. So it's a little bit lower than the center of pressure. So this is important for a FE exam. If you don't have time, for instance, you can eliminate some of the options by knowing where the force is acting. It will be a little bit further down, so you can make some educated guess if you're running out of time in the FE exam. So okay, so I finished the first surface, everything that is associated with it. We find the force, we find the center of pressure. If you look at the second one, you can see that the force is going to be like this, right? It's going to be Fz. There will be no Fy because it's a horizontal surface. So now let's take a look. How am I going to find it? Okay. One thing to note is this is given to me as 2 square root of 2, so which means that this from here to here is 2 meters. Okay. It's important. So the height, I'm going to need that. So that the whole height here is 3 meters plus 2 meters is 5 plus 2 is 7. So the height is 7. Okay. And the width is 2. I'm going to need that. Part B. So now, as I mentioned, my FP will be minus Fz because z was pointing up in the k direction. That's what I'm after. Okay. If you remember the vertical force, the formula was it's the weight of the fluid above it all the way to the free surface, whether the surface is real or imaginary. In this case, it is a real surface. So how this is going to look is this. So I have the width is 2 meters over here, and basically all the way through to the free surface is this distance I showed you before is 7 meters. The width is 2 meters. And basically I need to calculate the weight of the fluid that I have over here. So which is fairly doable. So the W will be the specific weight of the fluid that I have times the volume. This is the same thing as a mg, we just prefer this. This is 10,000, and the weight is, or rather the volume is 7 is height, 2 is width, 1 is going into the page. So what does it becomes? It becomes 14. So then Fz from here, I'm going to get my Fz to be 140,000 newtons, pointing it down. Okay. So this is the approach 1. I have an alternative approach here as well. And in this case, look at this. The pressure here is constant. Okay, so I can calculate my pressure. It's very similar to this approach. I can calculate my pressure. Once I know my pressure, which is constant this time around, it's not an average one, I calculate my pressure, multiply by area, get my force. So let's do that. Okay, F is equal to P times A. P is constant, so P is at that level. So now let's calculate P. P will be equal to specific weight times the distance that I travel down. In this case, 7, right? So it becomes 7 times specific weight is my pressure, so 70,000 pascals. So now I'm going to insert in here 7 times 10,000 times area. The width is 2, going into the page is 1, and you see over here it's the same thing. I get myself FC is 140,000 newtons, right? Just to clarify, this is 2 times 7 is 14, times this is 10,000, so I get myself 14,000. So then at the end of the day, my FP for surface number 2 becomes minus 140,000 in the K direction. So the next question is center of pressure. Where is this acting? Let me go up. Where is this acting? Well, that's actually the easiest question kind of ever, right? So it's acting in here, right? 7 meters from the surface, minus 7 meters from the surface. And in the, you can see it's going to act right in the middle, right? And if you have into the page, it will be 0.5 because it's still a rectangle.